Welcome to the seventh and final lesson on assessing the accuracy of remotely sensed data. We've come a long way in just 6 short lessons, and part 7 here is just going to be a summary and conclusions, making sure we tie up all the loose ends and make sure you're feeling good about the whole process. So this is a slide that I really like to look at and remind myself about. Because why are we making these maps? Why are we spending all this time with this spatial data? Why are we using the remotely sensed imagery? And then why are we assessing the accuracy of it? And so you can see this nice example here. Let's say we want to produce some kind of a wildlife habitat suitability map, and we've got 4 different layers, and we've assessed the accuracy of those layers. That would be wishful thinking because most of those aren't assessed these days, but hopefully we'll get to the point sometime where they all are. And let's say they were all 90% accurate. Okay, that would be really good. What's the accuracy of our resulting map? What's the accuracy of putting those 4 layers together? Okay, well, we can use our statistical knowledge, and statistics tells us that if those 4 layers are 90% accurate and we put them on top of each other, and the errors in 4 different map layers are independent of each other, then we would simply multiply the accuracies together. Okay, and so you would multiply 0.9 times 0.9 times 0.9 times 0.9, which gets you around 66% accuracy. And so if the errors in these 4 layers were completely independent, we would still be doing a pretty poor job, even though the layers were all 90% accurate. Now, luckily, that's not the case. Those errors are certainly not, independent of each other. What vegetation exists where has to do with elevation and has to do with streams, and what land use there is has to certainly do with water and elevation. There's a lot of relationships, between these layers. Okay, so if we assume that the errors in the 4 layers were in exactly the same place, in other words, they were 100% correlated, then the accuracy of the resulting map would be 90%. Okay, so we know that the accuracy is somewhere between 66 and 90% of our wildlife for our wildlife habitat suitability map. But that's not very encouraging. That's a pretty big range. And think about it some more. If we add another layer, a 5th layer, that's 90% accurate, we know that our accuracy range will actually increase. The 66% will go down closer to 58% or something like that. Okay, so it's just eye-opening to kind of think about that. The best way to know the accuracy of our habitat suitability map would be to do an independent accuracy assessment, right? We would use all the methods that we've learned already in this bunch of lessons and do a separate accuracy assessment just of that wildlife habitat suitability map. And that's probably a really good idea. But it's just eye-opening to think about maps that are very highly accurate, and still, when we put them all together, we can get some, results that we're not super happy with. So I hope that helps you to think about that a little bit more and puts in context the whole process of why you spent your time going through these lessons. Let me summarize a few key points and then make a few conclusions. So, things that you absolutely want to remember from these lessons. 1, there's no single way to perform accuracy assessment, right? There's no step-by-step process. There's no simple recipe. Instead, there's lots and lots of things to consider. There's many, many issues, and you need to take those all into account. Therefore, you need to be aware of them. Okay, so maybe you want to review these slides another time. Maybe you wish to get more into the details, find some papers in the literature, grab some books, whatever, so that you can think about all these issues and also read about other opinions. There's different ways of doing this, and there's certainly a bunch of opinions out there. I've tried to express in these lessons my experience with doing this, but as you know, I've really emphasized what you can achieve, okay? I haven't battled into the detailed statistics that are very, very interesting and very, very fun, but not very practical. Okay. And so you got to trade that off. So 3, it's really important then that you think about the assessment process before you begin your project. Okay? If you don't plan it ahead of time, if you get caught by surprise in the middle of your project, or even worse, at the end of your project, you're going to have to go back and do so many things over again. Okay? And we certainly learn more when we make mistakes. Okay, but the goal here is to learn from others' mistakes, and certainly I've made every mistake possible in accuracy assessment that you could possibly do, and trying to share my expertise with you here. Okay, and then lastly, as we've talked about, it's a balancing act, right? You're balancing statistical validity. It's no good to do it if it's not going to be valid. At the same time, if it's so statistically sophisticated that you can't even achieve it, then what good is that? Okay, so it's a balance between statistical validity and practical achievability. And that's a tough one. It's a tightrope. It's hard to walk that line. And that's why it's important to plan ahead to make sure you're thinking about what you're doing and doing the best that you possibly can. Okay, so here's my key points in conclusion. Absolutely, I'm sure you're convinced at this point that accuracy assessment is vital. We need that information. We need to know how good the map is. If we're going to use that map that you've made from remotely sensed data, or you're going to use the map that you've made, you got to know how good it is. It's absolutely key that you do that. The assessment process is expensive. It's a very expensive component of a project, okay? But it can't get out of hand. You don't want it to be half or 3/4 of the cost of the project. You can't afford for it to be, because so much of the rest of the project was expensive as well. So it's got to be well planned so that you're making the best use of every efficiency and being as effective as you possibly can. I can't emphasize that enough. Okay. Absolutely, right now the tools exist for you to perform an effective and valid assessment. Okay, so there's no excuse for that. You can't say, well, I didn't know how to do it, or it's not clear yet in the literature what you're supposed to do. That's absolutely not true. Okay, I've reviewed a lot of those tools that you can use, and you can certainly find other resources. However, you should know that because there's so much advancement, so rapid advancement going on in remote sensing, and especially in the increasing complexity of projects, that we absolutely need additional research and especially development in the field of accuracy assessment. We're not done with studying this. Okay, the error matrix is not the end all. I think we need to move so much beyond that. We need to get so much more practical. We need to produce information that's so much more useful to the map user. The error matrix is a good start, and it's taken us a while to get the techniques all together to do this. So we can do it now, but please be aware, if you really get excited about this, that there are certainly opportunities to do lots of different research and especially development if you come up with some new ideas for accuracy assessment. So my final point: document, document, document. Okay, it's so important that you describe how you did the assessment. I see way too many papers, and I get to review lots of papers for many, many journals, and I see people have a statement: overall accuracy was this. Yes, we collected some reference data from imagery, and that's all. No citations, no anything about sample size, nothing about sampling strategies, nothing about the sample unit, maybe no error matrix at all, no discussion. It's not sufficient. You got to tell us what you've done, because there's so many ways to do it, and there's so many wrong things that you could do. For a long time, people, again, were doing single pixel accuracy assessments. Some people were doing a cluster of pixels, but then they were counting every pixel in that cluster as a sample. Okay, so if it was a 9x9 cluster, they said they had 9 samples. That's not true. You have one sample. It's one sample unit. Spatial autocorrelation completely ruins the chance to be able to count that as 9 separate samples. You can't do that, but that's out there. There's lots and lots of issues. Okay. And so you've got to make sure, because there's so many considerations and so many choices. If you don't document it, then, we're not able to assess your map. We're not able to use your map, or at least it's not as good as it possibly could be. Okay. And that's a problem. We need to make sure. Okay. So please be wise about that. Please help your fellow researchers and your fellow map users out by writing some documentation about how you did your assessment. So thanks so much for viewing these lessons. At this point, you really should have a solid appreciation for the issues and the considerations that go into creating a valid, effective, and efficient plan for assessing the accuracy of maps made from remotely sensed data. I hope that you do. I made these lessons in modules so that you could go back and look at them again if there's a piece that you want to look at over again. Lots more detail in my book, the book that Cass Green and I wrote. If you're interested in that, there's chapters in other places. There's lots of places to find out information on how to do a valid accuracy assessment. So I do thank you for spending the time. I hope you enjoyed the lessons, that you went through the initial 2 little overview lessons, and then these 7 more detailed lessons. And if there's any time I can help you out or answer any questions that you might have, please feel free to contact me. I'd be happy to help out any way that I possibly can. I do thank you for your attention. Have a good day.